All right, what's going on, everyone? Today we are talking about Redux Saga and kind of what it is, what's the motivation behind it, how does it tie into the greater Redux ecosystem, and kind of like a real life example of how you would use it, how you would test it. Um, so if you're not familiar with Redux, what Redux is a state management library, right? So it's a central storage of your state in your app. So it's a place to not only store your data, but to be updatable from any part of your app, and to be able to in turn update any part of your app. So what is state? State is just your app's centralized persistent store of data. When we talk about state, we often ask, what is the current state of my application's data at any given point in time? So Redux Saga, and sometimes we just say sagas. Redux Saga is a third-party library which handles any application side effects like data fetching. If you have to like access your browser cache or your local storage, or even if you just want to use it as sort of an intermediary place to write your sort of flow of logic between different states. So we can use it to sort of implement kind of a state machine like flow of information. If you're not familiar with a state machine, we're going to talk about it more later, but the sort of the classic example is a traffic light. So a state machine describes, what are the various states that your thing, in this case your app, could be in, and how do the various states determine what the next state should be, or what the potential next states could be. So we'll talk more about state machines in a bit. Sagas can be super useful if your app incorporates some sort of third-party vendor logic. You can imagine if we had, let me get my other screen open here. If we have our company's app, so this is our app, and then we have some third-party, other company or other app. And for example, our app could be anything. It could be, let's say it's a pharmacy app, right? And what the third party does is all they do is they handle auth logic. So they basically store information about users, about their usage history, and they basically give our company, they provide us with basically a set of APIs and a set of components. In our case, I'm using React. It doesn't necessarily have to be React. It could be Vue, could be Ember, could be Vanilla.js, whatever you want for the front end. So they provide us with both APIs and components which handle our user actions, basically. So you can imagine, right, if we had our third party and they supply us with a list of APIs, so maybe like, login successful, login success, login failure, maybe like create new user, and then maybe like if this is all happening, if your login or your registration is is being handled in a pop-up modal window, maybe if you click out of that window, they have like a login aborted. So basically, there's various states that could be attributed to these various actions that are happening. You can imagine we could have any of this functionality live in our, or rather on our window object. So these would just be functions. You can imagine if this third party was just called, if it's just called auth, we could have functions called like, on our window dot auth underscore login. window auth register, something like that. So these are basically just functions that are being run when certain user actions are taken. So a very common pattern for this would be to use an event emitter. What an event emitter is basically in JavaScript, it's a type of class that has various functionality on it. And at its very sort of least verbose way of describing it, what an event emitter is it has roughly two things that it does. It can emit an event, and it can listen for an emitted event. So you can imagine if on a user action, if any of these functions are being run, if this functionality is being run, those could potentially emit an event, which we could then listen for in our app. Now, the issue with having local listeners, so emitted event listeners throughout our app, it's fine, but there's probably a better way we can do it. There's a central place that we can do it. Well, there's actually various ways we could do that, but one way of centralizing that listener logic is by using sagas to listen for those emitted events. And the way that we're going to do that is basically, instead of just emitting events, we are going to actually pipe those emitted events through our Redux store. And this is a super useful tactic as well, because the more information about our app we can have in this centralized Redux store, kind of the better, because then we just have it all in one place. So imagine you're using you're building a web app and you have a third-party vendor which handles user information. Like we said here, the auth information supplies your application with various pre-built components to access and update this user info, like a login modal, a registration modal, a sign out button. A common pattern would be to build an event emitter which emits useful information. So moving forward from that sort of pattern, your job is to make sure that any events coming from your third-party functionality are piped through Redux, and then you can listen for fired actions in your sagas. This is a better pattern than creating local event listeners because of the sort of granularity of control you get with sagas, and how you can, at a very, very detailed level, define exactly what you want to happen at each step of the way. It could even, fork off into, different possibilities, and then it makes testing very, very easy. All of Sagas is built on an ES6 concept called generators. What generators are, the way they work kind of in a nutshell, they're basically just functions that can be paused and then, wait for some action or something to happen, and then resumed, and then paused again, resumed. It can be forked off into other generators that can, access different pieces of state. It makes your flow of logic a very systematic way of going about it. Because sagas are built on generators and they have a very clearly defined API, it makes your code very easily testable. So when I am working in sort of an enterprise level solution, what I like to do, a pattern that I like to use, is to kind of build a state machine like flow of state updates. So for example, you can imagine a user would make a change in the UI. For example, they would click a login button, which opens a login modal, and this would create an action, something like login started. which is passed through Redux, and it may or may not be used. That's kind of up to whatever you need your application to do, based on how you need your state to be updated. You can create a default auth or authentication saga, which hooks into the Redux store and listens for this login started action. And whenever that's fired, it basically catches this fired action, and it can continue on to some other logic within the same generator function, or it can call another function, and that other function can be either a generator function or a regular function. So either way, it can then wait or basically listen for another user action, subsequent user action. This time either checking like checking login, currently checking, something like that, or like a login aborted if they click out. And then upon either authentication resolution or rejection, login success or login failure would be fired, and your Saga could then perform some additional logic. So a typical success login flow would be like authentication component initialized, and then login started, and then checking login, and then login success or login aborted. So it's like a very clear way of defining all the various different kind of steps that an authentication flow goes through, and storing all of that information in that centralized Redux store. And so going back to the traffic light example for state machines, think of it like there are basically three different distinct states that it could be in, right? Red, yellow, green, and each has its own logic around when that particular color, that light, is in the on state. For example, yellow has to come after green, red has to come after yellow, green has to come after red. So in the same way, you can build out your application's state control flow with very clearly defined pre-requirements that must be met in order to progress on to the next stage. So the way that I want to kind of show that is by showing you a small but very real application, at least in terms of the way that it is structured. So let's take a look at this. I'm gonna fire it up first and show you what it does, and then we can dive into the code. All right, so let's take a look at my app. Fire it up in the browser. So all that this app does is basically it's just a traffic light, right? So its default state is green, go. I can click this button to halt traffic, and it will go from green to yellow. And then after a few seconds, it will go from yellow to red. And then after a few seconds, it will go from red back to green, and then it'll stop. So let's see this in action. I'm gonna click halt traffic. So you see it has changed to red and stop. Then after 3 seconds, yellow and slow. And after another 3 seconds, green and go again. And this is where it sits, and this is where it stays, and this is sort of the default state. So it's very particular, the way that I wanted the flow of state to happen. I wanted everything to happen 3 seconds after the last thing. So it'd be a little bit more difficult to achieve this without some library like Sagas. So let me show you actually how I have done this. And I think, let's see, where's the best place to start? Well, let's go over folder structure first. So this is basically built on a Create React app. Let's take a look at the package JSON. I have React, I have my React DOM. This is all just standard Create React stuff. The only things that I have actually added in are Redux Actions, which we'll talk about, and Redux Saga. This is all just standard Create React app stuff. So it all kind of gets fired off in the index. If you're familiar with Redux, again, this is where we hook into the store, and the store is provided to the entire app. Where do we get the store from? We get it from configure store, where we set up our store. Let's take a look at that real quick. Okay, so this is important because this is where Redux Saga actually gets injected into the store. So in our call to create store, we have to actually add in our Saga middleware. And then we have to also run our root Saga. So the root Saga is going to be sort of like the index Saga that all our other Saga files are going to pull from. And in turn, that root file is going to be what actually connects to our store. So let's check out my Sagas. So I have a traffic light Saga folder, and then I also have my index. The index is the root Saga. This is where I have both the Sagas and the associated actions for those Sagas set up. Don't worry about that too much now. Just know that basically this default function right here in my root Saga is how we hook into Redux. And then in turn, in my individual Sagas like traffic light, and I have multiples for traffic light actually, those hook into my root Saga. And so the root Saga in turn hooks into Redux, and so on and so forth. So let's take a look at the app and see what's going on in my actual React code. If you're not familiar with React, this may be a little confusing, but I'll try to explain it in sort of as nondescript terms as possible. So we have our app being rendered. Inside of our app, we have some labels. We have our current status, which is just displaying the current color. It's pulled from state, and the current display is also pulled from state. We have a button with an on-click handler, and that on-click handler triggers a function called halt traffic, which actually is pulled in as a prop in our map dispatch to props function. So again, if you're not familiar with Redux, this might look a little bit weird, but Redux allows us to pull in both our state variables as props and also some functions which update our state variables as props. So we're able to access those all as regular props. I'm just destructuring them here in my app component. So it allows us to access them directly and hook into Redux state from our main component. Okay, so what happens when I actually click that button and it halts traffic, right? Because remember, my default state is green go. So when I click this halt traffic on click handler, it calls this dispatch function, which is hooked into our Redux state. So let's take a look at where that is actually coming from. It is coming from our traffic light reducer. All right, so remember that halt traffic. So what is halt traffic? It's just a function. It's a function which creates an action based on the constant that I've declared in a different file, which basically just tells us stop, right? So let's take a look at that real quick. Let me look at my actions. So I have, again, this is like a pretty standard folder layout. So I have my constants in that I have my actions. Why do we do this? It's basically just to remove the possibility of spelling errors. So I have my stop action is just a string stop. So going back to my reducer, my traffic light reducer, when I call halt traffic, all it does is it uses this predefined Redux function called create action, which based on this string, which is it just refers to the string stop, it creates an action and subsequently automatically, because this is an iffy, it's an immediately invoked function expression. it automatically fires it to the reducer. So it automatically fires into my traffic light reducer an action with type stop. And in turn, it will return the state as it was in the initial state, but I have appended on and therefore changed the color to be red and the display to be stop. And we'll see, you know, if I didn't have sagas in place, that's where this would end. But sagas in the background are actually listening for this fired action, this traffic light stop action. So we can actually see that in our traffic light stop saga. So this has a default function, which basically is listening for every stop action fired to Redux. And it's making use of this take every effect. Redux Saga has a whole bunch of different effects that you can use, like call, put, and take every. There's way more. They have a pretty clearly defined API. You can definitely go check out the docs for that. But what take every does is basically it just means that every time a stop action is fired, it will call this function halt traffic. So it's listening for every time this stop action is called, or rather fired off to Redux, and then it will in turn call halt traffic. So when we click this button the first time, this halt traffic button, it will call in turn this halt traffic function, which is another generator function. Notice that all of our generator functions have the star symbol in front of it. That just denotes that it is a generator function. So this halt traffic function will first put, which means basically just create an action and fire it to the Redux store. So it will fire an action, traffic light sequence initiated. That basically, I don't think I even ended up using this, but it basically just lets us know that the Redux flow, or rather the Saga flow, is currently happening. So it fires that off, and then it calls this sleep function. Now sleep is a utility function which I've written. And again, if we go back into our src file, I have some utilities, and I have some Saga utilities, and in this I have a function called sleep. And all this sleep function does is it basically just returns a promise which resolves after however many seconds you pass it. So going back to our Saga, so after we're passing it 4 seconds, after 4 seconds it will basically return and move on to the next line, in which we call the function fire slow traffic action, which is itself another generator function. And all this generator function does is it will create and fire off an action with type traffic light slow. So remember, we were on green originally, we were on go originally. We click the button, it fires off a stop action, and then it goes through this flow that we just looked at here, and then it fires off a slow action. And then what's going to happen, I have a different Saga file for slow, and in my default function for slow, it's listening for every slow action fired off to the Redux store. And when it hears that, it will call the slow traffic function, which will sleep for 3 seconds, and then call fire go traffic action, which is another generator function, which will fire off an action with type go, and also fire off an action which says that the sequence of Saga events has ended. So that's basically the entire flow. That's the entire flow of what my Sagas are doing here. So going back to the button here, when I click halt traffic, it's going through my stop Saga, and then after 3 seconds, it's going through my slow Saga, and then it is firing off my go again, where I don't have another Saga listening for go. I don't have any Sagas listening for go at all. So it stops there. That's the entire sequence of functionality. Now, what's interesting, well, one of the many interesting things about Sagas is that the APIs, put, call, take every, makes it very, very easy to test. Very easy to test. So going into my stop test file, I've written out a bunch of tests, and each one of these tests corresponds to a different one of these generator functions. So in my test file, ignore the imports for now. I have a high level describe, which just describes the entire file. And then I have 3 describes, 1 for each generator function. Let's start at the bottom one. This default action refers to the default function here. So basically all it's doing is it's using this library. Check it out at the very top here, this first import, Redux Saga testing utils. So I'm going to extract something called clonable generator from my testing utils library. This is a third-party library. You do have to import this, and then it sits in your node modules. So I'm going to extract something called clonable generator, which gives us a testable mock of the generator that we're currently working with. So we pass it a reference to default action, which again, default action is basically just a reference to this entire default function here. So we create a cloned generator that is then testable, and then we basically the way that generators work. I'm not going to go super deep into generators, but when we call a generator, it returns an object which has various next properties, which gives you basically whatever happens next in the sequence in that generator function. So when we call generator.next and grab its corresponding value for this first, where did it go? Stop Saga. So for this first function, we should expect the first next to do all of this take every call, listening for a stop action. So we should expect this first next value to equal that entire evaluation of take every. And that is where the power of testing sagas comes in, because you don't really have to go, it's just super easy to basically just grab whatever the functionality that you were doing in your actual saga and then just say, I expect the next thing in the sequence to be that entire use of that effect, right? Similarly, well, we'll see in a minute how the other effects work similarly, like call and put. But basically, we can go from there, right? So that was the first. That's the default action. The next one we can look at is halt traffic. This corresponds to this halt traffic generator function. So the first thing we should expect, the first next value we should expect, is a reference to put, passing in this fired action. So we can again clone a generator based on that halt traffic function. And then we should expect, I think I did these out of order actually. Oh, you know what? No, this was added later. So actually this is interesting, because this will force us to do a little bit of live coding. So I should expect the first thing that should happen in this test for this particular halt traffic generator function. I should expect the first next to yield an evaluation of this put effect. So I'm going to write a new test here. So I should expect the first thing to happen. So I'm going to say puts action sequence initiated. I'll write out my test. And this is jest here, but you know, work a similar way for chai, mocha, karma, whatever your flavor is. So I would expect the first generator next value to equal, and I have this entire expression copied. I should expect it to equal all of that right there. And so from there, I should expect the next yield to be a call to sleep. And I should expect the next value to be a call to fire slow traffic action, and so on and so forth. So that is just the testing file. Well, actually, we didn't even talk about the other. Right, so we have a third generator function here, fire slow traffic action, which we should only expect one next value, which would be a reference to this expression put with slow. So we have that right here in this first describe. So that's just the testing for this stop Saga file. I also have tests set up for my slow Saga file here. Which I think actually, because I did pause the sequence at the end of this, I need to write in a test for that as well. So I am going to write a test in my fire go traffic action. Let's see. Fire go traffic action describe here. So I should expect my second test here to, I should expect it to put sequence paused. Puts sequence paused. Sloppy. So I should expect, again, generator next value to equal an evaluation of put here. So let me actually run my test suite here, and we can debug from there. So I'm going to run, and it looks like we're all good. I do still have some console logs in my code base, but I'll leave those in for now. I would never actually ship that, but that's okay if they sit there for now. All right, I'm gonna leave off there for now. Obviously, this is just sort of a quick intro to sagas. There's a million different other ways you could do it. A million different other things you could do with sagas, and the API is enormous for it. So let me know what you think. Leave comments, anything I could have clarified better, could have explained better, any lingering questions, comments, drop them in the comments below. I'll be happy to answer them to the best of my ability. And thanks for watching.